Good morning, algebra students. Today we're going to simplify those monomial square roots with variables. First, we'll respond to our do now. And we have to think about our essential question as we work, because this is crucial to our work. So think about, how do I simplify a monomial square root if the exponent is a multiple of 2? And how do I simplify a monomial square root if the exponent is not a multiple of 2? So what's expected of you today is to complete the do now, the 2 work pages, the exit ticket. If you're a distance learner, make sure you submit photos on Teams, and if you're in person, you show your work to me. For homework tonight, please do homework 11, monomial square roots, and I want you to remember that Wednesday is our unit test. So our exit ticket, we will come back to that in a minute. I want you to take a few minutes and think about this question. This question has to do with feeling lonely. Sometimes people feel really alone, but we do have phones, the internet, and available adults at school. If you were feeling very alone, what are 3 things you could do immediately at the very moment when you feel the loneliest? And it happens to me a lot because I live alone. I like to read good books, watch a little TV, sew, Sudoku puzzles, call a friend, all kinds of things. So I want you to write those there, and if you feel so inclined, you can add to your answer down here. So let's get started with the lesson. Now, here are the basic rules. Square roots with variables are known as monomial square roots. Just like numbers, the variables can be simplified. And here's our rule. When we're given the square root of a to the m power, we're going to look at m. If m is a multiple of 2, we're going to use the rule a to the m power, the square root of a to the m power equals a to the m divided by 2 power. And remember, if we get to 1, that 1 will be invisible. But here's the trick. If m is not a multiple of 2, we're going to break it apart. So where m is not a multiple of 2, we're going to break it apart to the square root of a m minus 1, thus making it a multiple of 2 times a to the first power. So let's see how that works. Well, in this case, we have the square root of x squared, and the square root of anything squared is going to be itself. So the square root of x squared is x. So think of it this way. If you have the square root of 6 squared, well, that's just going to equal 6, because the square root of 6 squared asks, what is the square root of 36, which of course is 6. So that's the first one. So then number 2, we look at the exponent. What is the square root of m to the 6th power? And the exponent is a multiple of 2. So the square root of m to the 6th power will be m to the 3rd power. We just divide it by 2. So why don't you try, let's go all the way through 6 and then come back to the video. Okay, so let's see how you did. We have a square root of 9k to the 2nd power, so that would be the square root of 9 is 3, and k, 2 divided by 2 is 1. That's our final answer. The square root of 64p to the 4th power, well, the square root of 64 is 8. P, 4 divided by 2 is 2. And that's the final answer. Number 5, the square root of 100 is 10. X, 2 minus 2 is 1. Y, 2 minus 2 is 1. And those exponents of 1 become invisible. And then number 6, the square root of 49, a squared, b to the 6th, c to the 4th. The square root of 49 is 7. And a, 2 divided by 2 is 1. B, 6 divided by 2 is 3. And c, 4 divided by 2 is 2. Let's move on to, now we have those square roots that are not a multiple of 2. They're not divisible by 2 evenly. So we're going to have to break it apart. So this will be the square root of y, 5 minus 1 is 4, times the square root of y to the first power. So these exponents have to add up to the 5. So now we evaluate the left side, the square root of y to the 4th power. We use the first rule. We're going to use the first rule on the part that is now a perfect square. So that would be y to the 2nd power. And this is sort of prime, so we just have to express it in that way. And that's our final answer. That's how you leave it. So let's look at number 8. So it would be the square root of a squared, because that's a multiple of 2. B, we have to do 3 minus 2 is 2 times the square root of b to the first power. So then we evaluate the left side, which would be the square root of a squared is a. The square root of b squared is b, because 2 divided by 2 is 1. B, 2 divided by 2 is 1. Those will be invisible ones. And then we have this kind of remainder, which is the square root of b, and that becomes an invisible exponent of 1 as well. So let's look at number 9. So square root of x squared y, 3 minus 1, is 2. So we're going to have to put another y over here. And then we have our z to the 4th. Now let's work on this left side. The square root of x squared is x. The square root of y squared is y. The square root of z to the 4th is z, 4 divided by 2, which is 2. And then we have our remainder with an invisible exponent of 1. Number 10, the square root of 144 is 12. Well, let's not go there yet. Let's actually show all our steps. So we're going to have the square root of 144. K, 3 minus 1 is 2 times the square root of k. So this is a perfect square. So this will be 12. K, 2 divided by 2 is 1. So that will be an invisible 1. And then we have the square root of k. And that's our final answer. And number 11 and 12. So number 11, we're going to have to work with that 7, that exponent of 7. So it will be the square root of 81 r to the 6. That means we need to put an r to the first power here. Remember, it's kind of like the opposite of, remember when we multiply, we add monomials. When we divide, we subtract. So we're subtracting 1. So this will be s to the 4th. And we'll evaluate the left side. 9 r, 6 divided by 2 is 3. S, 4 divided by 2 is 2. And then we have our remainder with an invisible exponent of 1. Okay, number 12. The square root of 196, that's a perfect square of 14. C, 5 minus 1 is 4. D, 2. So we've got to put that c to the first power on the right. We'll evaluate the left side. So that would be 14. C, 4 divided by 2 is 2. D, 2 divided by 2 is 1. That will be an invisible 1 times the square root of c. Okay, on to our second page. So 8 is not a perfect square, but 8 is 4 times 2. So let's get our radicals ready. So we got 4 times 2 on the 8, and then we have x to the 6th power. So the square root of 4 is 2. The square root of x to the 6th is x to the 3rd. Then we have that square root of 2, and that's our final answer. Number 14, 50. The largest square in 50 is 25. So that'll be 25 times 2. So we're going to have the square root of 25 times the square root of 2. And then we have x squared. No variables on the right side this time. So the square root of 25 is 5. The square root of x to the 2nd power is x. we bring in that remainder, and that's our final answer. Number 15, 68 can be thought of as 4 times 17. So we have square root of 4 times the square root of 17. And p, we have to do 3 minus 1, which is 2. That means we still have a p on the right side. So let's work with the perfect square side. The square root of 4 is 2. The square root of p squared is p times 17p for our final answer. Number 16, 45 can be thought of as 9 times 5 because 9 is a perfect square. So then we have n, 11 minus 1 is 10. That gives an n over here. So when we evaluate the perfect square side, we have 3n, 10 divided by 2 is 5 times the square root of 5n. So I hope you're trying a few and then just coming back and checking. Get really strong at these, not too hard. 27 can be thought of as 9 times 3, 9 being our perfect square. So this x has an exponent of 1, so it's going to have to go over here. It's not a multiple of 2, so we're going to go ahead and put y16 here. So x is going to end up in our remainder. So on the left side, the square root of 9 is 3. Y16 divided by 2 is 8 times the square root of 3x. Number 18 can be thought of as, you can go 36. 36 times 5. And 36 is the largest perfect square in 180. You need your calculator to, if you're not very strong with some of these numbers, you can use a calculator to help you, but you should get used to dividing larger numbers. So on the x's, we're going to have to do 3 minus 1 is 2. That puts an x over here. And then we have our y to the 8th. So the left side is our perfect square side. The square root of 36 is 6. X, 2 divided by 2 is 1. Y, 8 divided by 2 is 4. And our remainder that cannot be factored into perfect squares, square root of 5x. Number 19, well, we're going to use 16 times 10. I don't think there's a larger perfect square in there. So 16 times 10. Remember, this side has to be a perfect square. Okay, so a, we are going to have to subtract 1. So a to the second, that puts an a for 1 over there. And then we have b to the 6th. So the left side is our perfect square side. For a, 2 divided by 2 is 1. B, 6 divided by 2 is 3. And then our 10a here. Number 20, we're going to think of that. Again, 36 is going to help us. 36 times 3. And r to the 18 can stay here, but s, we'll have to subtract 1 from the 13, making it 12, and put an s on the right side. So on the perfect square side, we have 6. R, 18 divided by 2 is 9. S, 12 divided by 2 is 6 times the square root of 3s. And that's our final answer. And then number 21. We can think of this as 36 times 2, square root of 36 times the square root of 2. And we have m. 9 minus 1 is 8. We need to put an m here. N, 12, p, 2. So let's evaluate our perfect square side. 6, m, 8 divided by 2 is 4. N, 12 divided by 2 is 6. P, 2 divided by 2 is 1. That's an invisible 1 times the square root of 2m, and that is our final answer. And then on number 22, 63 can be thought of as 9 times 7, square root of 9. I think we're going to need a lot of room for this one. So x, 5 minus 1 is 4. Put an x on the right side. Y, 25 minus 1 is 24. Put a y on the right side. Then we have our z, 14, can stay right there. Let's evaluate this left side. The square root of 9 is 3. X, 4 divided by 2 is 2. 24 divided by 2 is 12. And z, 14 divided by 2 is 7. And then we have our 7xy. You'll use this skill a lot in Algebra 2. Again, number 23, we're going to multiply 36 times 7 to get that 252. So 36 times 7. Now x has an exponent of 1. It's got to come over here. We have our y squared, and z, 3 minus 1 is 2, which means we have to put a z over there. So the square root of 36 is 6. Y, 2 divided by 2 is 1. Z, 2 divided by 2 is 1, times the square root of 7xz. And number 24, 392 can be thought of. This is a 196 times 2, and 196 is 14 times 14. So let's see, A2 can go over here, B2 can go over here. C, we're going to have to subtract 1 and put it over there. So the square root of 196 is 14. A, 2 divided by 2 is 1. That's an invisible 1. The same with B and the same with C. And our remainder, 2C with invisible square root. So good work. Let's go back to our exit ticket and complete that. So if the exponent is a multiple of 2, we're going to use the rule the square root of a to the m power equals a to the m divided by 2. If the exponent is not a multiple of 2, then we're going to break it apart. So in this case, a to the m power, where m is not a multiple of 2, will equal a to the m minus 1 times a. So we can put an example there. Let's use r. Square root of r to the 7th power will be the square root of r to the 6th power times the square root of r, which will equal r to the 3rd square root of r. So good job today. I'm proud of how you've practiced. Make sure we'll do some review tomorrow. Wednesday, we have our unit test. Please do your homework and go back over your notes. So your homework is going to be due, your interactive notebook will be due, and make sure you study for your test. So great job, and keep up the hard work, because with extra practice, you'll be great.